back into all solutions. Now your sine curves and your cosine curves are endless. So your solutions should also be endless, right? So we're not doing restricted angles anymore. Now, when you solve a trig equation, it's very much like solving an algebra equation. So if I take this out, and I just go like this, how would you solve this? What's the first thing you're going to do? Add 1. You're going to do the same thing to your trig equation. This is your variable right here. You're going to add 1. You do the same thing that you would do to any algebraic equation. Then what would I do to my algebraic equation? You would divide by 2. Now, here's your answer in your algebraic equation. We divide by 2 over here, and we finish the algebraic part, but we're left with the trig part. That's why these are trig equations. We do all the algebraic solution parts, and then at the end, what it's telling me is this. I have an angle, any angle, not a restricted angle, whose sine is 1/2. Now, let's first work on your unit circle. Sine is the x or the y? The y. So, we need to be where the y is positive, which is which quadrant? 1 and 2. If you want to remember, all students take chemistry, or if you just, I like to go, the y is positive, the y is negative. The x is positive, the x is negative. That's how I like to work them. But if you like to do, all students take chemistry, calculus, whatever, that's fine with me too. So we know in the unit circle, in 2 pi, we have 2 solutions, right? So we label y over r. And for those of you that can't do this yet, you really got to step up your game here. 1, 2, and what angle is this reference angle? 30. So now, we have an angle that goes here, and we have an angle that goes here. Now, I want these in radians. We're going to work radians. How many times does 30 go into 180? 6 times. So it's something pi over 6. So in quadrant 1, it is pi over 6, right? In quadrant 2, this would be 6 pi over 6. This would be 12 pi over 6. What's 1 less than 6? 5. Okay? So far, in 2 pi, we only have 2 solutions. Now, if you remember your sine curve, here's your up to 2 pi, right? So our solution where it's 1/2 was over here. When it's 30, when it's 150. Okay, we can keep this going again. Up, we've got 2 more. And we can keep this going again. We have 2 more. We can go back here. We have 2 more. So your sine curve is endless. It keeps on going and going and going, doesn't it? So our solution between 0 and 2 pi are these 2. If I want all possible solutions, then I have to keep on going forever and ever. So if this adds up to 2 pi, I'm going to add another 2 pi. Remember doing coterminal angles? And we took this guy and we added 2 pi to get there, didn't we? So we could add 2 pi to get there. We could add 4 pi to get there. We could keep adding to get there. Do you see what I'm saying here? We can keep going with this and going with this. We can do the same for this angle. We can add 2 pi. We can add 4 pi. We can add 6 pi. We can keep going for endless solutions. Now, if we're going to keep doing this, we could write it like this. Pi over 6 plus 2n pi, where n is any integer. We can do this to this guy. plus 2n pi, where n is any integer. Now, any integer is this. At the 0, I'm right there, my originals. When n is 1, I went 2 pi. When n is 2, I went 4 pi. When n is 3, I went 6 pi, right? All I need to do is keep finding coterminal angles, basically. Coterminal angles add another 360, another 2 pi. When I do this, because I multiply it by 2, it gives me all the even ones. Okay? So we're going to say I add 2 pi to n pi, where n is any integer. So this gives me all solutions forever, for infinity. Because doesn't the sine curve go on to infinity? Right? And every 2 pi, I have 2 more solutions. 4 pi, 6 pi, 8 pi. I got 2 more solutions every time I do that. Okay, we start with your regular unit circle. We locate where sine is positive or negative. In this case, we wanted the positive. We find our 2 angles. And in this case, we add 2n pi. Just give me another one, another one, another one to each one. Make sense?
Miss Park, I'm still not understanding how you know that that's 6 pi at all. Because it's 3 pi regardless. Like, just
3 pi would bring me here.
So why is
Because if I go here, let's start with this guy, pi over 6, right? Are you okay with pi over 6?
Yeah.
Now, if I come around, I'm here, to make a coterminal angle, I can come all the way back around and add a full circle. Add 2 pi to this guy, right? I'm having to add 360 degrees. Let's work in degrees for a minute. If I add 360, I'm now at 390. I'm going to add another 360, and then I'm at 750, something like that, right? I add another 360. So technically, I'm just adding 2 pi plus 2 pi plus 2 pi. It'll always bring me back to that little edge right there. I keep adding 2 pi. So if I say 2n pi, where n is an integer, when n is 0, I'm here at my original 1. When n is 1, I just added 2 pi. Remember, I'm adding 2 pi. When n is 2, I'm at 4. I got to make a complete circle. Every 2 pi is a complete circle. So this 2 out there makes me know that I'm an even number. I don't want to say n pi, because n pi, then you're right, I would add 3 pi. 3 pi is only half of a circle, I'd be down here. So I want to keep this even. I start like this. Add 2 pi. Add 2 pi. Add 2 pi. I keep adding 2 pi and 2 pi and 2 pi and 2 pi to what I have. So essentially I'm adding 2, 4, 6. I'm going right even.
How do you know that it's that axis? Like, how do you know 6 pi is not like straight up and down?
Because I'm going to start here from this terminal side and make a coterminal angle. 2 pi brings me a complete circle. Another 2 pi, which gives me 4 pi, gives me a complete circle. Another 2 pi, which gives me 6 pi, gives me a complete circle from that angle. So that's why we have to do it from this angle and from this angle. We have to go complete circles from the terminal side. Okay, watch. Here's an angle. Guys, listen to me. Here's an angle, 30 degrees. Give me a coterminal angle.
180 plus 30.
So what is 180 plus 30? 210. Where is 210? 30. I wanted to terminate right here. I wanted to have, coterminal means it has to share that side. I have to share that side. So how do I get back to that spot?
Oh, never mind. So it wasn't.
Now 180. What brings me back around to a complete circle? 360. And what is 360 in terms of radians? 2 pi. So I take 30 plus 360 in degrees, pi over 6 plus 2 pi in radians, right? Now, I'm here. I came all the way back around. I want another angle that's coterminal to this. What should I add to it now? Another 2 pi. So what's 2 pi and 2 pi? 4 pi. So I take this guy and I add 4 pi. So that's 30 plus 720. So that's pi over 6 plus 4 pi. You see what's happening? Guys, visualize where your angle is. Visualize where your angle goes. Yes. Yeah. Okay, let's start. Okay.
We should do baby steps. Like first we just do the circle.
Well, the problem is, I don't think you guys have a concept of 360 and 2 pi. All right. Here's my original problem here. Now, I'm going to work this out over here. I'm going to make my sine of x be x. How do I solve this algebraic problem? I got to solve for x. To add x, and I'll have nothing on the side. Subtract this. Got to get this guy by itself. Get all your x's together. Right? So far, so good. Let's do that on this side. I need to get this sign over there. Subtract sine x. So now in your algebraic one, how do I solve for x? By what? Negative 2. So over here, I need to solve for sine of x. Divide by negative 2. Does this ring a bell to anybody? Radical 2 over 2 is what angle? What reference angle? 45. Isn't it 1 over radical 2? Rationalize? Radical 2 over 2? Now, it's negative. What quadrant is sine? Sine is your y. Use your axis. Where is your y negative? Down here, 3 and 4. So you've got a triangle in 3 and a triangle in 4. Remember, these come off your circle. So you told me this was a 45. I'm going to unrationalize that in case you can't see it. So there's my 1, 1, radical 2. There's my 45. Now, 45 goes into 180 how many times? 4. So it's something pi over 4. That's my 45-degree angle. So what should I label instead of pi? What should I label this side? 4 pi over 4. I want it to reduce to pi, don't I? What should I label this side where it's doubled? 8 pi over 4. Now, can you name me this angle that's 1 past 4? 5 pi over 4. Can you name me this angle that's 1 before I hit the 8? 7 pi over 4. Okay, so I've got inside of my 2 pi, I have 2 solutions. Now, I want all possible solutions. So what do I add to both of them? 2n pi, where n is any integer. Won't this bring me back around? If I'm here, this is my terminal side. If I go from here to here, this is my angle, 5 pi over 4. If I add 2 pi, don't I get to that? Then I add another 2, oh, that gives me 4 pi. Then I add another 2, oh, that gives me 6 pi. That's my coterminal angle. Good so far?
So suppose you just multiply to get 4 pi over 4 as the axis. No, I keep asking.
No, go ahead.
You just multiply by what the number. So
I technically don't multiply. Watch, Abby, watch. In your unit circle, this is 0. What's this? Pi. Okay, so now I've got a denominator of 4. So this denominator was 1. Make me an equivalent fraction. Over 4. Ah, it's 4 pi over 4. This was 2 pi. Make me an equivalent fraction for 4. 8. Because aren't you doubling? You take this, you want this to cancel out to pi. So the numerator and the denominator have to be the same, whatever your bottom number is here. So if it's a 60-degree angle, how many times does 60 go into 180? 3. So this guy over here would be 3 pi over 3. What would this one be? Double 6 pi over 3. It gives you a placement without having to convert your angles.
Okay.
Yeah.
So that one with 6 pi over 3 would reduce to 2 pi, right?
That's what you started with, your 2 pi. So if you're going to use a denominator of 3, then you're doubling 6 pi over 3. You reduce it to 2.
That's just no, not even the whole thing.
With the fraction parts.
Yeah, that's what I was.
The end is any integer. It could be 0, 1, 2, 3. It'll keep making me go every 2, every 2, every 2.
Is that for everything or just
Just, no, it's for any angle that has a placement where I have to add 2 pi to it. And another 2 pi, and another 2 pi. Because if I did this, 2 pi, and then I added 2 more, I'm now 4 pi. Then I'm 6 pi. I'm all the even numbers. If I didn't have this 2, and I said any integer, I'd be odd numbers. So that 2 makes me have all even numbers.
For the sine, it would always be plus 2n pi. Or
If it's that I want to come all the way around full circle, plus 2n pi. Anytime I want to come around, because I need to come back around to this guy. I need to terminate in the same spot. I can't make a different angle. Okay, Brianna, did I answer your question? No.
so when you do x equals 5 pi over 4 or x equals 7 pi over 4, like I saw you do that with the other one, because you put x equals 5 pi over 6.
Yeah?
Because you put one over 1 under, but they were different angles. Like this one's 45 and the other's 30, so I don't get why.
Process is the same though. The only thing that was different was your reference angle. It's your reference angle that drives this original one.
So no matter what the angle is, we just do 1 up or 1 under.
Well, it depends where we land. Like, if this one both happened to land, the other one landed up top here, so I was one before it, and I was in the original one. So your angles come from this direction all the time, all your positive angles. So as you're coming through here, watch. This is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. Because you're 45, it's nice because it's a half. Now we did the 30s before. The 30s had 3 in each. But the thing is, you'll never have to go 2 down, because if you do 30 plus 30, you're 60. And we have our own for 60. So it really works well to find your placement. Okay, you always take this reference angle, divide it into 180 of your 2 special triangles. It's either going to be pi over 3, pi over 6, or pi over 4. Okay, that's a very good question. Now we've got another little thing here. We want to know what the solution is between 0 and 4 pi. Okay, now we're going to start like this. Okay, now I just want you to think out loud a second. Once we add 2 pi to this, how many radians will we have gone if we add another 2 pi? So if I've already have 2 pi in here, and I add another 2 pi to get to here, isn't that where my 4 pi goes now, from 0 to 4 pi? Don't I want one more complete cycle if I'm going to go to 4 pi? What does your circle go to now? Your normal unit circle goes from 0 to 2 pi. If I add another circle, I'm going to go from 0 to 4 pi. Technically, I want one more set of angles to this. So if I'm looking for my coterminal angle, I'm going to add another 2 pi to that guy, aren't I? Don't I have to add 2 pi to this? So add 2 pi, add 2 pi. Agree? I'm just going around the circle one more time. Now, they have fractions. So the easiest way to do this is to convert this. 2 pi over 1. My denominator is 4. Just convert it once. What does my top number become? 8 pi over 4. So I'm going to add 8 pi over 4. What's 5 and 8? 13 pi over 4. So take this out, add 8 pi over 4. What's 7 and 8? 15 pi over 4. So now I have 4 angles. This one and this one in my first circle of 2 pi. In my next circle of 2 pi, I have this one and this one. I have 4 angles in 2 pi, don't I? 2 in the first 2, 2 in the second 2. Agree? Okay? We're moving around your circle in a number of times because isn't your sine curve, your cosine curve endless? Doesn't it go on and on forever? It's a tough concept, I realize that. It's a tough concept. Now, all right. We okay with this? All right, let's try another one. This one's going to throw you a little bit. But you got to put your thinking caps on. What you guys hate to do is think in radians, and I keep saying you got to get used to the radians. Okay, here's my problem. How do I solve for the tangent of x? Subtract 3. Okay, I got to isolate my tangent of x. Then divide by 3. And my tangent of x is what? -1. And tangent is which part of my graph? Y? Oh, okay, I'm sorry. So you're in here already, right? Okay, so 1 is positive, 2 is negative, 3 is positive, 4 is negative. So I'm y over x, aren't I? So I got a special triangle. What's my reference angle? 45. Okay? How many times does 45 go into 180? 4. So my angle that I'm looking at, my reference angle, is this. Not my angle, this is my reference angle. So I'm going to make this 4 pi over 4. I'm going to make this 8 pi over 4. So as I come around the circle, this is my 1 pi, 2 pi, 3 pi, 4 pi, 5, 6, 7, 8. Makes sense, right? 1 every 45. That's half of your 90. So what comes before 4 pi? So this guy is 3 pi over 4. And what stops before 8? Okay? Now, normally we say, if we want all solutions, we say add 2n pi, where n is any integer. Agree? Now, that works. That certainly works for us. However, tangent usually has a nice little situation because where the period of sine is every 2 pi, what's the period for tangent? How long does it take me to complete a little segment of my tangent graph? I go pi over 2 this way, I go pi over 2 this way. So what's the period for tangent? Pi. So tangent has a special situation as well as for your cotangent, but the tangent will say this. If I just take this guy and I add pi to it, don't I get this one? Then if I add pi again, don't I get this one? And add pi, and add pi, and add pi, and add pi. Aren't these 180, half of a circle away? So I can condense this and just say x equals 3 pi over 4 plus n pi, where n is any integer. I knew it was going to stop working on me. Where n is any integer. Do you see why? Your period of tangent is 180. Your period for sine is 360, 2 pi. So therefore, you can just work from here to here. It's kind of like, I think the 180 is almost easier to spot because you're from here, there, here, there, here, there. It's like half of your circle. So half of your circle is 180. So we can condense this and do this. Okay? Now, one more second. The solutions for 0 to 4 pi. If I have 2 from 0 to 2 pi, how many should I have from 0 to 4 pi? 4. So I'm going to take this guy, and I'm going to add n pi. Now, I need to add n pi, but what's my denominator? I need to convert to fourths. So how many am I technically adding? 4n pi. So let's add 4n pi. So I add this and I get 7 pi over 4. Add another 4n pi to this. What do I get? 11 pi over 4. Add another 4. What do I get? 15 pi over 4. Add another 4. 19 pi over 4. I said, how many would I find? If I found 2, I'm only going to find 4. I really went kind of crazy here. So sometimes what's nice is to take this guy and convert this to 4, the same denominator. I can only go to 16. So do I really want the 19? No. Do I have 4? 1, 2, 3, 4. Didn't we say we would get 4 in 4 pi? So the rule is this. This is how I do this. I take where my endpoint is. I convert that to my denominator. It tells me where to stop. Then I convert my 2n pi or my n pi to the same denominator, and that's what I keep adding. Once I hit my limit of 16 pi or whatever your limit is, you stop. Yes. We don't have to do that for that because we only have to do it. Didn't we catch a 7, 4, and 5 in here? Because it went every 180. Okay, now I'm going to give you this for homework, and I want you to